Alright, Algebra 1, here we go. 8-2, multiplying and factoring. Our essential question is, how can you use the distributive property to multiply a monomial and a polynomial? Well, you're going to do all the things that we've been doing. The distributive property is the distributive property. You multiply the numbers like you multiply numbers out front and add exponents on like basis. So everything kind of comes together here. Example here says simplify x cubed, negative x cubed times this. Remember there's a 1 right there, okay, so don't forget it. So it's just a matter of multiplying the negative 1x cubed times each of these. So negative 1 times a 9 is negative 9. X to the third times x to the fourth, add exponents, x to the seventh. Negative 1 times a negative 2 is a plus 2. 3 plus 3 is x to the sixth. Negative 1 times a positive 7 is negative 7. X cubed, no x is there, so you get x cubed. Okay? Remember there's a 1 right here, we just don't always show it, n to the first. 5 times 3 is 15. 1 plus 3, common base, n to the fourth. 5 times a negative 1 is negative 5, and 1 plus 2 is n to the third. 5 times 8 is 40, n to the first, there's no n's, nothing to add, so it's 40n. Okay? Nothing new there. We've been doing stuff like that already, this just kind of kicks it up a little bit. But now factoring, that's a little different story. Okay? How to factor? Well, what is factoring? Well, factoring is the opposite of what we just did here, multiplying. Here we had two factors. Remember, you multiplied two factors together to get a product, answer to a multiplication problem. Here's a factor, here's a factor. Okay? Here's our product. When you're factoring, you take the product and you want to break it down into this. Okay? What are those things that you multiply together to get that? Okay? What we're going to look at here today is pulling out the greatest common factor. What do they all have in common? Okay? The way the book presents it is this. Let's say we want to factor 5x cubed plus 25x squared plus 45x. Okay? What we want to factor out are those common factors that they share. The greatest common factor. Okay? Because sometimes, especially when you're looking at even numbers, you might be able to pull a 2 out, or you might have been able to pull a 6 out. Okay? So let's factor completely, take out the biggest common factor. So what the book does is they look at prime factors. Remember prime factors, 2, 3, 5, 7, 11, 13. Numbers that only 1 times themselves are factors of it. So prime factor 5 is just 5, and remember x cubed just means x times x times x. 25, the prime factors are 5 times 5. You can't break those down any further. X squared, x times x. 45 is 9 times 5, or 3 times 3 times 5, times the x. And then look and see what they all have in common. They all have at least one 5, and they all have at least one x. Okay, you're always going to find that when it comes to the variables, whatever the smallest exponent of the one that they all have will end up being your greatest common factor. So the 5x is going to go out here. And now where did this come from? Okay, one way to look at it in your mind is to say, take that greatest common factor and divide it into each term. 5 goes into 5 once. 3 minus 1 is x squared. Boom. 5 goes into 25 5 times. X squared over x. 2 minus 1 is x to the first. Boom. 5 goes into 45 9. The x's cancel out. 1 minus 1 is 0. X to the 0 is 1. 9. Okay, that's where it comes from. Let's take a look at another example. Okay. Doing like the book, I took each factor and now I want to break it down. 4 is the same as 2 times 2, and then x to the fifth would be 5 of them. 24, you can look at it as, let's say 4 times 6, and 4 is 2 times 2, and 6 is 2 times 3. So 2 times 2 times 2 is 8, times 3 is 24, x cubed. 8 is 2 times 2, which is 4, times 2, which is 8, x. Okay? What do they all have in common? Let's take a look here. Looks like to me they each got a 2. Okay? And they each got at least one x. So what's my greatest common factor? 2 times 2 is 4, 4x. Okay? So I'm going to take my 4x to the fifth minus 24x cubed plus 8x. I'm going to get my 4x for my greatest common factor. What's going to go in the parentheses? Well, I'm going to take that greatest common factor. Now, you may not always write this down. Once you get good at it, you'll just kind of do it in your head. But I'm going to take this, write it out so I can see it, and I'm going to do it. 4 and 4 cancel out to 1. 5 minus 1 for exponents leaves me x to the 4th. So 4x times x to the 4th is 4x to the 5th. Minus 4 goes into 24 6 times. 3 minus 1 is 2. So I'm going to get 6x squared. 4 times 6 is 24. X to the 3rd power. 4 goes in 8 twice. The x cancels. Boom. 4 times 2, that's 8x. So when you multiply this, you should get back what you started with. Okay? One more time. Here we go. 14, whoops. Let's do this in blue. 14n to the 3rd power. 14 is 2 times 7, and then n. 35n squared, that's 5 times 7, n. 28 is 4 times 7, so that's 2 times 2 for the 4 times the 7. What do they all have in common? They all have a 7, and that's it. So my greatest common factor is 7. So to factor this out, 14n to the 3rd minus 35n squared plus 28. There's my greatest common factor. What's going to go in the parentheses? Well, let's divide them each by 7. Okay, 7 goes into 14 twice. That's 2n to the 3rd. Goes in there 5 times. 5n squared. Goes in there 4 times. And there it is. Okay? If you distributed this back out, you'll get back what you started with. Okay? We're going to do a lot of work with the factoring. This is just the beginning of it, looking at a greatest common factor. Does take a little work. You got to kind of think in reverse of what you've been doing, but you can always check your answer to see if it's right by multiplying it out and see if you got what you started with. Okay? We're going to look at this for the next couple of days. We'll get after it tomorrow. See you then. Bye.